End behavior. End behavior describes what happens specifically to the y values as our x values increase to positive infinity and as the x values decrease towards negative infinity. In Algebra 2, you would have learned about end behavior. We are going to answer the same questions, but this time we're going to describe end behavior in terms of limits. So I have a visual of a graph down below, and I'm first going to review what potentially you did previously when you had to identify end behavior. So we're only looking at what is happening as the x values get really large or really small. So it doesn't really matter what's happening in the middle of the graph, we're only focusing on the end, hence the name end behavior. So on the right hand side of the graph, you'll notice that the y values are going up as the x values get larger. On the left hand side of the graph, as the x values get smaller, the y values are going down. So how we describe that? In the past, you may have said f of x, which is our fancy notation for y, approaches positive infinity as x approaches positive infinity, meaning as the x values get really big towards positive infinity, so do the y values. Then on the other side, we would have f of x, again, our fancy notation for y values, approaches, so that arrow means the word approaches, negative infinity as the x values also approach negative infinity, meaning they get really small. A really important thing to notice is that every time you do end behavior, you're going to have two solutions. One for the right-hand side of the graph, and the second for the left-hand side of the graph. Now I'm going to take our end behavior notation and I'm going to write this in limit notation. So we write the word lim, that stands for limit, with an x, the arrow meaning approaching, and then we have our infinity sign, and then we label the graph of f of x. This is our f of x. And we say that the limit as x approaches infinity, so this is the x values that we're talking about, and our answer is going to be our y values. So in this case, the limit as x approaches infinity of f of x is equal to, so what are the y values doing? They're going towards positive infinity. So this is the answer because of that positive infinity that we outlined before. The entire thing is describing end behavior. Oh, look what happened there. The entire thing describes end behavior for the right-hand side. So let's do the same thing on the left-hand side. So we write the limit as x approaches negative infinity, so that's giving our information for the left-hand side, of f of x is equal to negative infinity. And the reason why this is negative infinity is because we had negative infinity as we outlined end behavior earlier. So this is our limit notation, describing the exact same thing as what we did here on the left-hand side, but writing it with limits, which is what I'm going to ask you to do this year. We can also describe end behavior from a table. The concept is still the same. We're looking at the center. Remember, we don't really care what's happening with the center of the graph. We care what's happening as x approaches positive infinity, and we care what happens as x approaches negative infinity. So we're going to look at the y values from the table. On the left-hand side, the y values are getting exponentially smaller. So they're going towards negative infinity. And on the right-hand side, the y values are getting exponentially larger. So they're going towards positive infinity. So now we're going to write this as a limit. Remember, we have two, one for each side, the left-hand side and the right-hand side. So we write the limit as x approaches negative infinity of f of x is equal to negative infinity. And on the right-hand side, we have the limit as x approaches positive infinity of f of x is equal to positive infinity. Both of these together are the answers for end behavior.